Hello friends, I am Kailash, PhD Chemistry, Kendriya Vidyalaya Pasighat is going to discuss a topic electrical and magnetic properties of solid from the chapter 1 solid state class 12 science. First of all, I am dealing with the electrical properties of the solids. As we know that solids can be classified into three categories based on electrical properties. First is conductors, then insulators, and then semiconductors. As these terms are self-explanatory, means conductors which conduct electricity, insulators which do not conduct electricity, while semiconductors which can or cannot conduct electricity depending upon the conditions in which they are held. Starting from conductors, a 27-point scale varying from 10 raised to power minus 20 to 10 raised to power 7 ohm inverse meter inverse is used to measure the electrical conductivity of the solids, and the conductors fall in the region between 10 raised to power 4 to 10 raised to power 7 ohm inverse meter inverse, and insulators fall in the region between 10 raised to power minus 20 to 10 raised to power minus 10 ohm inverse meter inverse, and semiconductors fall in the region between 10 raised to power minus 6 to 10 raised to power 4 ohm inverse meter inverse. Next is conduction of electricity in the solids, that is band theory. It means that why some solids conduct electricity, why some solids do not conduct electricity. It is very well explained by the band theory. Before starting the band theory, I am going to discuss what does band mean. As we know that an atom is having atomic orbitals which in turn combines to form molecular orbitals. A large number of molecular orbitals are formed if a large number of atomic orbitals combine. If large number of atomic orbitals combine, instead of forming lines, these form series of lines, seems like bands. Then two types of bands are formed. One is conduction band, which generally do not contain electron, and second is valence band, which contain electron. And one gap is maybe there, that is known as forbidden gap. Conduction band is having more energy as compared to valence band. Now comparing the conduction of electricity in different kinds of solids, the classification of solids as conductors, insulators and semiconductors can be done on the basis of energy bands of the solids. In case of metals, there is no gap between conduction band and the valence band, means the empty band, that is conduction band, overlaps with the valence band and electrons are present in the conduction band, so electrons can easily flow, which leads to conductivity of the metals or conductors. While in case of insulators, the forbidden gap is very large, so electrons tends to remain in the valence band. They cannot jump from the valence band to the conduction band, so these do not conduct electricity. Now let's go to the semiconductors. As semiconductors are having small gap between conduction and valence band, so on acquiring some energy, that is from the electric field or even from the temperature, the electrons can jump from the valence band to the conduction band, which leads to conduction of electricity. With an increase in temperature, the conduction increases. Substances like silicon, germanium show this type of behavior and are called as intrinsic semiconductors. As we increase the temperature, the more electron can jump due to increase in kinetic energy from the valence to conduction band, and hence more conductivity will be there. However, at the absolute zero temperature, the electron will remain in the valence band, and hence semiconductors behave as insulators. The conductivity of these intrinsic semiconductors is too low to be of practical use. Means they cannot be used practically. To use these in practical terms, we have to add some amount of soluble impurities. This process is known as doping. It increases the conductivity of the semiconductors. The doping can be done by adding with a small amount of impurity. It may be electron-rich or electron-deficient atom as compared to intrinsic semiconductor, that is silicon or germanium. Such impurities introduce electronic defects in them and form extrinsic semiconductors. Either these produces extra electrons or this produces holes. So these are responsible for the more electrical conductivity of the semiconductors. First example, electron-rich impurities. As silicon is having 4 valence electrons, so it can form 4 covalent bond. When doped with the group 15 elements like phosphorus or arsenic, when we dope silicon with the arsenic or phosphorus, as phosphorus or silicon is having 5 valence electrons, so the silicon atom is replaced by the phosphorus or aluminium. The remaining 5th electron that is present is responsible for the electrical conductivity of the semiconductor. As one extra electron is present, which is negatively charged, hence silicon doped with electron-rich impurity is called N-type semiconductor. You can see in the diagram, one free electron is there. Second is electron deficient impurities. When silicon or germanium doped with the group 13 element, that is boron, aluminium or gallium, which contains only 3 valence electrons, the silicon atom is replaced by the gallium or the element group 13 element. It is having 3 valence electrons. The place where 4th valence electron is missing is called electron hole or electron vacancy. Electron vacancy is created due to presence of only 3 valence electron. Now, if electric field is applied, the neighboring electron jumps to the hole, and it seems that the hole is created at the origin position of the electron. It seems that when electric field is applied, the hole is moving towards negative charge and the electron is moving toward positive charge. As this type of semiconductor is generated with the help of positive charge, that is hole, so this is known as P-type semiconductor. Now some applications of the N-type and P-type semiconductors. Diode is an electronic circuit, and it is a combination of N and P-type semiconductors, and it is used as rectifier. Rectifier is a device which converts AC into DC. You can see different types of diode in the diagram. Next is transistor. These are made by sandwiching a layer of one type of semiconductor between two types of other type of semiconductor. There are two examples, NPN and PNP type of transistors. These are used to amplify or detect radio or audio signals. We have seen these in electronic circuits. These are devices with 3 legs. It's another example, important example. The solar cell is an efficient photodiode used for the conversion of light energy into electrical energy. Some other applications are there. 13, 15 compounds. These are formed by the combination of group number 13 and group number 15 elements. Examples are indium antimony, aluminum phosphide, gallium arsenide, etc. Gallium arsenide is very important as it is used nowadays as semiconductors. 12 to 16 compounds. These are formed by combination of group 12 and group 16 elements. Examples are zinc sulfide, cadmium selenide, mercury telluride, etc. As cation is from group 12 and anion is from group number 16, as in case of 13-15 compounds. Some transition metal oxides like titanium oxide, chromium dioxide, rhenium trioxide behave like metals. The rhenium trioxide is having metallic copper-like conductivity and appearance. It is a brownish red in color. Now, some transition metal oxide, like vanadium oxide, vanadium dioxide, vanadium trioxide, titanium trioxide, behave as conductors and insulators at different temperatures. Some important examples of transition metal oxides. Okay, thank you. This was all about the electrical properties of the solids. The next part I am going to discuss magnetic properties of the solids. Thank you.